For activity 2, we're gonna build our circuit to test and verify this voltage and current relationship here using this triangle way we just talked about in the lecture. So here is the circuit we're gonna use. DUT here is our capacitor because it's the device under test. And the reason we put the capacitor in series with this resistor here is because we need to use a oscilloscope, but the oscilloscope cannot measure current directly. So we put the resistor here and measure the voltage and divide the voltage by its resistance to get the current through the circuit. And also we want to make sure this resistor is small enough so we can approximate the overall voltage as the voltage across the resistor.
All right. Now we have our circuit for activity 2. It's pretty simple. It's just a capacitor in series with a resistor. So now we look at our input power supply, which is our function generator. It's set at 50 kilohertz with a triangle wave, and the amplitude is set at 5 volts RMS. All right. Now we connect our input to the circuit. All right. So for the measurement, we're gonna use oscilloscope. We have 2 channels. We want to put the first channel across our input. And the second channel across the resistor. So now look at the oscilloscope. Now we have our input signal. Output signal. Before we want to do the measurement, we want to adjust the reference level of both channels to the middle. So to do this, we need to select each channel, make sure the coping is DC, and adjust the reference level to the middle, and do the same thing for the second one. All right. Okay, so now we can do the measurement. So if we look at our values of interest, for this activity, we want to measure the current in both channel 1 and channel 2, using these 2 equations. All right. So for channel 1, this equation is basically the current for going through the capacitor. We already measured C, the capacitance, is this value. Now we need to measure dV and dt. So dV is basically the peak to peak voltage from the negative to positive peak, and dt is the time interval between the negative peak and the positive peak. So if we look back at our oscilloscope, we just look at the yellow signal. We want to do the measurements, we need to use the cursors. And the cursors button will bring up 2 cursors. We put one cursor at the negative peak, another one at the positive peak. And we look at these small windows here. The time interval is 10.6 microseconds. And the peak-to-peak voltage is 16.8 volts. So now we write down this value. 16.8 volts and 10.6 microseconds. All right. So for your task, you need to use these values to calculate the current. All right. So for the channel 2, we are because channel 2 is measuring the voltage across the resistor. To get the current, we just simply use the Ohm's law, V divided by R. We already measured R. In this case, it's 99.01 ohm, and we need to measure V here. So V, because our voltage is a EC voltage, to calculate to measure the V, we only want the 0 to peak voltage. So instead of peak to peak, we want 0 to peak. All right. So if we look back at our signal and we switch to channel 2, we put one cursor at the positive peak, another one at the negative peak. So you see the peak to peak voltage is 344 millivolts, and 0 to peak voltage is actually half of this value. So what we get is 344 millivolts, but divided by 2. All right, so it should be about 172 millivolts. All right. So for this part, yeah, you also need to use those measured values to calculate the current, and comparing these two currents, see if these two are the same.